Now we will going to take up one more problem on the cantilever beam, the problem number 6, and it reads as find the reactions at the fixed end and draw the SFD and BMD for the beam loaded as shown in the figure. Locate the point of contraflexion, if any. So here we have one end is fixed at A and the other end D is free, and between C and D you have a uniformly variable load, which is 20 kilonewton meter at C and 0 at D, and have a span of 2 meters. Then at the point B, we have 30 kilonewton, which is acting downwards, which is at a distance of 2 meters from A, and also the counterclockwise couple of 100 kilonewton meter at the point B. Now, first we are going to find out what are the reactions at the fixed end. To find out the reactions at the fixed end, so at the fixed end, we have horizontal reaction, we have the vertical reaction, and we have the reactive moment, all the three. So first we are going to consider sigma h. So as there is no horizontal load which is acting on the beam, so naturally RAH will be equal to 0. Now when you are considering the vertical reaction, RAV, see sigma V will be equal to 0. So the load acting upwards is positive if you are considering by convention. So here RAV is acting upwards, so it is positive because we are considering all the loads which is acting from the downward direction toward the downward direction, which is being shown here. In order to keep the beam in the equilibrium condition, therefore RAV should be acting upwards. So the convention is the load acting upwards is positive. So therefore RAV minus 30 minus area of the triangle, which is half into 2 into 20 in case of uniformly variable load. So that will be equal to 0. So on simplification, RAV will be equal to 50 kilonewton, which will going to be acting upwards. Now we will going to consider the moment, which will, some of the moments will be equal to 0. The clockwise moment is considered positive and the counterclockwise is considered to be negative. Sorry, the clockwise couple will be equal to the counterclockwise couple, and the counterclockwise couple is negative and the clockwise is considered to be positive by sign convention. So to do that, so taking the moments about the point A, so what will going to be this minus MA plus 30 into 2 because it is the clockwise couple, minus 100 because it is the counterclockwise couple, plus half into area of the triangle, that is half into 2 into 20, and the distance of center of gravity, which is from the bigger end, which is 1 by 3 into the span is 1 by 3 into 2, and that distance with respect to A will going to be 1 by 3 into 2 plus 3, which will be half into 2 into 20, which is the area of triangle, into 1 by 3 into 2 plus 3, which will going to be the distance of center of gravity from the bigger end to the point A from the fixed end. So on simplification, which will going to be MA will be equal to 33.33 kilonewton meter in the counterclockwise direction. Now once you get this, now we will going to start analyzing from free end towards the point A. First we are going to consider only the reaction of the area of the triangle of the uniformly variable load varying from D, which is at 0, to C at 20 kilonewton per meter. So to do that, so first we are going to consider between C and D, which is the triangle, which is 20 kilonewton per meter at C, and at D, which will going to be 0. So which is having a span of 2 meters. So SF at D will be equal to 0, and then SF at C will be equal to half into area of the triangle, that is half into area of the triangle, half into base into height, that is half into 2 into 20. So on simplification, you will going to get plus 20 kilonewton. So here you are getting from 0 to 20 kilonewton. So the line joining between these two will going to be a curve. What is the curve? The curve is a parabolic because since it is the area of the triangle, that is meter square, since the power is 2, therefore it will going to be a parabolic curve. So between C and D, the SF varies parabolically due to UVL. Now we are going to consider the bending moment at the point D. So the bending moment at the point D will be equal to 0, and the bending moment at the point C, as the load is acting downwards, Therefore, the beam will going to try to bend in the downward direction. So naturally, it will going to be a hogging bending moment. So that means by sign convention, it will going to be negative. So the area of the triangle into the distance of center of gravity from the bigger end, which is the bigger end, it is from C. So here, minus half into 2 into 20 into 1 by 3 into 2. So that means minus half into 2 into 20 into 1 by 3 into 2. So on simplification, you will going to get it as minus 13.33 kilonewton meter. So the bending moment varies from 0 to minus 13.33 kilonewton meter in a cubic law, because this is the area of the triangle and the distance of center of gravity will be in meters and this will be meter square. So the power will going to become meter cube. So naturally, since the power is 3, so the curve joining between 0 to minus 13.33 will going to satisfy the cubic law or the cubic curve. So therefore, Pm varies accordingly from 0 to minus 13.33 kilonewton meter according to the cubic law due to uniformly variable load. Now we will going to consider between C and B. At the point B, we will going to consider only the vertical load. We will not going to consider the counterclockwise couple. So when you're considering that, what happens, we'll see. So then between B and C, as we can see, between C and B, as there is no other load acting upon, so therefore it remains constant at 30 kilonewton. SF at B will go into what happens. SF at B, the point load is acting, which is of 30 kilonewton. So therefore, it will going to be plus 20 plus 30, which will going to be plus 50 kilonewton. So we can see at the point B. So here, between C and B, as there is no other load, it remains constant at 20 kilonewton. At the point B, then suddenly the load increases to 50 kilonewton because due to the point load at B, which is acting downwards at 30 kilonewton. So then what will going to be the bending moment at the point B? The bending moment at the point B will be equal to, so minus half into 2 into 20 into 1 by 3 into 2 plus 1. So minus half into 2 into 20 into 1 by 3 means, that is 1 by 3 into 2 means 2 by 3 plus 1, which will going to be minus 33 kilonewton meter. So the line joining between 13.33 kilonewton meter to 33.33 kilonewton meter by a linear line. Now, when you are considering, now we are going to consider the couple, the counterclockwise couple is also acting at this point B. So now we are considering the counterclockwise couple of 100 kilonewton meter. So what happens, since the shear force, we are not going to consider the moment, we are not considering the counterclockwise couple, therefore SFD will going to remain the same. So what happens to the bending moment diagram? The bending moment diagram, you're going to have minus half into 2 into 20 into 2 by 3 plus 1. Since it is the counterclockwise couple, so the bending moment will going to sag. So naturally it will going to becomes positive. So plus 100 on simplification, you will going to get it as 66.67 kilonewton meter. So then what happens? The bending moment will going to increase suddenly from minus 33.33 kilonewton meter to plus 66.67 kilonewton meter because due to the counterclockwise couple acting at the point B. So that is what we got here, from minus 33.33 to plus 66.67 kilonewton meter, sudden rise due to counterclockwise couple. Now we will going to consider between B and A now. As there is no other load is acting between B and A, SF remains constant, which will going to be at 50 kilonewton. What is the shear force at the point A? The shear force at the point A will be plus 50 kilonewton only. So at this point also, SF at A, you will going to have plus 50 kilonewton. So what will going to be the bending moment at the point A? The bending moment at the point A will be equal to minus half into 2 into 20 into 2 by 3 plus 3 plus 100, then minus 30 into 2 on simplification, you will going to get it as minus 33.33 kilonewton meter. So now the bending moment will going to drops down from plus 66.67 kilonewton meter at the point B to the minus 33.33 kilonewton meter at the point A. So by doing so, what happens? So their bending moment is changing its sign from positive to negative at the point E. This point is called the point of contraflexion. So what will going to be the point of contraflexion? Let this point distance be x meters from D. So once you are considering that, so here we will going to have the shear force diagram and also the bending moment diagram which is acting at the point of x meters. So how to find out that? So to do that, what will going to be the bending moment at the point E? So the bending moment at the point E will be equal to 0 because at this point the bending moment is changing its sign from positive to negative. So at this point E will be bending moment E will be equal to 0, but we need to find out what is the distance. So the distance will going to be minus half into 2 into 20 into the distance of the center of gravity from the free end we need to consider, because the total distance from here to here is x minus this distance from the center of gravity to the free end. If you are considering, that will be x minus 2 by 3 into 2, x minus 2 by 3 into 2. So that will going to be the distance from here to here. So once you get this, then you are going to have plus 100 minus 30 into the total distance is x minus 3 will going to give you from this point to this distance will going to be x minus 3. So minus 30 into x minus 3. So on simplification, you will going to get which is equal to 20, minus 20 into x plus 26.67 plus 100 minus 30 into x plus 90. So that will be equal to minus 50 into x plus 216.67. So on simplification, x will going to be 4.33 meters. So the point of contraflexion will be 4.33 meters from the free end. So that is what we are going to get. X will be equal to 4.33 meters from the free end. So, but if you are considering from the fixed end, what will going to be the distance? So 50 into x will be equal to 33.33. So on simplification, x will be equal to 0.67 meters from the fixed end. So D or 0.67 meters from the fixed end A. So this is how you will be able to analyze and solve this particular problem. Thank you.